Okay, so now I'm going to find the class big O theta of and omega for a given function n square plus 1 raised to 10. Okay, so as I said, this is like n square raised to 10, so n to the 20. So if we want to find the big O of it, let's choose a function that is slightly greater than this. So we'll say n raised to 21. So we'll use the limit. So limit n tends to infinity, n square plus 1 raised to 10 divided by n to the 21. So I can say this is n times n square raised to 10. So I can take this n square inside. So limit 1 n tends to infinity 1 over n times n square plus 1 divided by n square, the whole thing raised to 10. So it is 1 plus 1 over n square raised to 10. So now if you apply the limit, it is 1 over infinity is 0 times 1 plus again is 0, so 0 times 1 is a 0. So which means the numerator goes um, slower compared to the denominator. So n square plus 1 raised to 10 is always less than n to the 21. So I can say it's big O of n to the 21. Okay. Now for theta we can just choose n to the 20 because we want to grow at the same rate. So n square and 10, so n to the 20. So then this can be written as n square, the whole thing raised to 10. So it's 1 plus 1 over n square. Limit n tends to infinity is going to be 1 plus 0. So that's going to be 1 raised to 10, so 1. So I can say n square plus 1 the whole thing raised to 10 is n theta of n to the 20. Now for big omega we want to choose something that's going to be less than n to the 20. So let's choose something to be n to the 10. Okay, so if that is the case, n's limit n tends to infinity n square plus 1 the whole thing raised to 10 divided by n to the 10. I can say I can get this n inside, so n square plus 1 divided by n the whole thing raised to 10. So it is n plus 1 over n raised to 10. So when you apply the limit, it's going to be infinity. So n square plus 1 raised to 10 is going to be going faster compared to n raised to 10. So it's going to be big omega of n raised to 10. Okay, so same thing with this. Square root of 3n square plus 7n plus 4 is equivalent to square root of n square, so it's n. So if you want to find big O, let's choose n square to be your big O of g of n. So n square can be written as n to the power 4. So limit n tends to infinity square root of 3n square plus 7n plus 4 divided by square root of n to the power 4. So this is limit n tends to infinity square root of 3n square plus 7n plus 4 divided by n to the 4. So this is limit n tends to infinity 3 over n square plus 7 over n cube plus 4 over n to the power 4. So that's going to be, when you apply the limit, this is going to be 3 over infinity 0, then this is 0, this is 0, so whole thing is 0. So I can say it is big O of n square. Okay. So with theta I can say this is equal to square root of n square, right? So it's going to be n. So I can say my g of n equal to n, and this is square root of n square, so I can bring the n square inside the square root. So it is 3 square root of 3n square plus n plus 4 divided by n square. So it is 3 plus 7 over n plus 4 over n square. So if you apply the limit, it's going to be square root of 3 is a constant. So I can say this whole thing is theta of n. Now for big omega, so let's say we want to find something that grows slower compared to this. So let's choose our thing to be square root of n, g of n square root of n. So it is square root of 3n square plus 7n plus 4 divided by square root of n. So I can take this n inside the square root. 3n square plus 7 plus 4 divided by n. So that's going to be 3n plus 7 plus 4 over n. As n tends to infinity, this is infinity. Okay. So this is going to be big O of square root of, so big omega of square root of n. Okay. Okay, so this is matrix multiplication. So if matrix multiplication, you have a simple summation like this: I equals n 0 to n minus 1, j equals 0 to n minus 1, k equals 0 to n minus 1. Okay, so that's going to be upper limit minus lower limit plus 1 kind of formula. So the I and j summation holds as it is, but n minus 1 minus 0 plus 1. So it's going to be n. I can take this n outside and repeat the same process. So I can take n outside and repeat this as 1. So it's going to be again an n. So outside is already n, so it's n squared. So I can take again outside, so it's going to be again leading to an n. So it's n cube. Okay. Now the summations, I want to compute the sum of these. 1 plus 3 plus 5 up to 999. So I can say this is 1 plus 2 plus 3 plus so on, because you see here this is sum of odd terms. So I'm going to introduce even terms. So I can say it's 1 plus 2 plus 3 up to 999 minus, I introduced all the even terms. So it is 2 plus 4 plus 6 plus 8 up to 998. So now I have this as summation of n terms. So it's going to be n times n plus 1 over 2. So 999 plus times 1000 over 2 minus 2 times, this is 1 plus 2 plus 3 up to 499. So this n I can write as 499 times 500 over 2. So it is 999 times 500 minus 499 times 500. So I can take the 500 outside as common. 999 minus 499, that is a 500 again. So that's going to be 500 times 500, which is 250,000s. Okay. Then 2 plus 4 plus 8 up to 1024, we can say it is 2 to the 1 plus 2 square plus 2 cube up to 2 to the 10. But if you want to apply the formula, we have to have 2 to the 0 in it. So you can add 2 to the 0 and then subtract later. So you have 2 to the 0 plus 2 to the 1 plus 2 square up to 2 to the 10 minus 1. So the formula is going to be 2 to the 10 plus 1 minus 1 divided by 2 minus 1. But 2 minus 1 is a 1 in the denominator, so it's 2 to the 10 plus 1, which is 2 to the 11, the whole thing minus 1. We already have another minus 1 over there, so it's 2 to the 11 minus 1 minus 1, so 2048 minus 2, which is 2046. Now this is sigma I equals 3 to n plus 1, 1. So we can now apply the upper limit minus lower limit formula. So it's n plus 1 minus 3 plus 1. So it is n plus 1 plus 1. So n plus 2 minus 3. So it's n minus 1, which is theta of n. Then we have sigma I equals 3 to n plus 1 I. So now we can apply the limits for values of I and see where the function grows. So it is 3 plus 4 plus so on up to n plus 1. Okay, so you can see essentially I am lacking this 1 plus 2. If I introduce 1 plus 2 here, I can write it as 1 plus 2 plus up to n plus 1 minus 1 plus 2, right? So that is n plus 1 times n plus 2 over 2 minus a 3, which is theta of n square, plus a constant, you can say, but it is theta of n square. Okay. Then sigma I equals 0 to 1 second. Okay. So sigma I equals 0, I times I plus 1. So I can say it is sigma I equals 0 to n minus 1. I can get the I multiplied, so it's I square plus an I. Okay, so this is the easier way to do it. So this is I square plus an I, the whole thing. So sigma I equals 0 to n minus 1 I square plus sigma I equals 0 to n minus 1 I. So if I apply the formulas, it's going to be for I square, it's going to be n times n plus 1 uh, times 2n plus 1 divided by 6. So either way, if you substitute all the n time instead of n minus 1 and solve for it, you will get this. The first summation is that of n cubed, and this is that of n squared. So I can say the whole thing is still that of n cubed. Okay, so j equals 1 to n, 3 to the j plus 1. So we can put for j is 3 square plus 3 cube plus up to 3 to the n plus 1, right? So actually you can do it like this: 3 times 3 to the j, right? I can take the 3 out, so it is going to be well, if you want to apply the formula from, you have to have from j equals 0, right? So j equals 0 to n. So since I am introducing 3 to the 0, I'm subtracting 3 to the 0, which is negative 1, right? So this is going to be 3 to the n plus 1 minus 1 divided by 3 minus 1. Just this term. Just this term is going to be 3 to the n plus 1 minus 1 divided by 3 minus 1. So it is 3 times 3 to the n plus 1 minus 1 over 2 minus 1. So over 2 will come here. So it's going to be 3 to the n plus 2 minus 9. Okay, if you do the simplification. So that is still theta of 3 to the n. That's what I would say. Okay. So we'll stop with this.